Welcome, friend. I've got a geometry problem here for you. Let's zoom in on the part that we need to pay attention to. We're supposed to find x, which is right here. You're not done yet. We have to find out what x equals. So what information are we given in this problem? Well, I've got 9.7, which is the length of this chord right here. That's not really even a chord, it's just a piece. And this is 22.4. That's going through the center, so that is a diameter. So the whole thing is 22.4. So a radius would be half of that, and that would be 11.2. And this one would be 11.2. Okay, so how is that going to help me find the x? This whole piece right here is a radius. It's going from the center out to the circle. So it's going to be the same length as these guys. So that's also 11.2. If there was some way to find out what this chunk was right here, the bottom part of it, we could subtract that from 11.2, and whatever's left over would be what x is. So is there some way of finding this? If you look here, there's a right triangle. And if you can find a right triangle from your first semester geometry class, you probably have a memory of the Pythagorean theorem. A squared plus b squared equals c squared. I think this will do it. Let's set this up. So I'm going to have a squared plus 9.7 squared equals 11.2 squared, because in this right triangle, that 11.2 is the hypotenuse. It is across from the right angle. Okie dokie. Let's get going on this then. That's going to be the setup. 9.7 squared. 9.7 squared is going to be 94.09. Let's get the 11.2 squared since I'm here. 125.44. So let's fill that in. All right. Now, to get to a squared needs to be by itself so we can solve for a. I'm going to subtract 94.09 from 125.44. 31.35. And our a will be what we get when we take the square root of 31.35. Make sure you don't do all your work on a calculator. If you're in a class and your papers need to be graded, you're going to have to put this on paper so your teacher can follow what you did. And we end up with 5.5991. And I'm going to round that to 5.6. Okay, so to find our x, we're going to do the 11.2 radius, the entire length of that red line, and we're going to subtract what we got for a. And that's going to give us, eventually, 5.6. Okay, well, that's cool. I mean, we got the same number that we subtracted, so it looks like this is splitting that in half. Is that a theorem? It might remind you of a theorem, but it's not. Let me show you what I'm talking about. Will this chord always split this one in half if this is 90 degrees right here in the corner? Right now that angle is 97.3. I've got these two things split in half right now, but I need to make that 90 degrees. Like, it's not going to be a true statement unless it's like always true. It was true for the problem we just did. These are not the same length. So if it's a theorem, it has to be true all the time. If you see a 90 degree angle, do the two red lengths actually are the same all the time? Come on, do it again. I had it. Boom. No, and again, they're not. So that is not the theorem. Where you're getting that mixed up is if you have a diameter or a radius intersecting a chord at a 90 degree angle, it makes these two pieces on the side equal to each other. So this could be a diameter if I kept drawing it. But that is true. And no matter how big the circle is, if this is 90 degrees, that radius will split the side to side pieces of that chord that goes from this one. That gets split in half, but not this one. And even though that's what we got on the problem we just did, you can't assume that's going to be true all the time. You would still have to do it the way we did it with the Pythagorean theorem. Thank you guys so much for watching. God bless, guys. See you next time. Bye.